This video lesson is a recap of the first half of Chapter 6 from Pre-Calculus. The first thing that I have to make sure I emphasize a lot is that you study the unit circle. Remember how the unit circle kept coming back and affecting a lot of what we did during Chapters 6 and 7, and I would say that's about 50% of the final. Okay, evaluate using unit circle. So where is pi? And when it says tangent, you have to think of sine over cosine. This is the point -1, 0. Sine over cosine is 0. Number 2, 3 pi over 2. 1 out of 2, 2 out of 2, 3 to 2 are due south. The sine is the second number, and that would be -1. Okay, let's just make a note here. A lot of this right here, when it says unit circle, and a lot of Chapter 6 was with no calculator. And so that is going to be on the no calculator part of the final. Okay, 11 pi over 6. This one you might have to wrap around a little bit. 11 pi over 6. 6 out of 6. Oh, isn't this one right here right before 12 out of 6? And so it's the first one. This value, this number right here is the same as this first one, except it's down here. And that's going to be radical 3 over 2. Okay, number 4. Negative pi over 3. Remember, when it's negative, we're going to have to swing down a little bit. So we're going to swing down to the pi over 3 spot. Okay. Secant goes with cosine. The cosine value here is 1/2, positive. And so I'm going to reciprocate that and get a 2. Okay, let's keep going here. 17 pi. So we're going to have to figure out where 17 pi is, and then I can think about the sign. 1 pi, 2 pi, 3 pi, 4 pi. I'm getting kind of tired. Maybe what I'll do is say an odd number of pi has to be over here. And all the evens are over there. So it's definitely going to end right here. And sine is the second number. We've got -1, 0. And so the answer is 0. -7 pi over 6. Don't forget to swing down. Okay, swinging down. This is 6 out of 6. 7 out of 6 is going to be right here. Right there, the first one. So let's just go ahead and write down the coordinates of the point. We've got negative radical 3 over 2, comma 1/2. Tangent is sine over cosine. So cotangent must be cosine over sine. If I take this fraction and divide by that one, I'm going to cancel out the 2's, and the answer is negative radical 3. Make sure you fill out the unit circle a couple of times and study those values. Okay. The next thing we did was converting to radians. And so when you want radians, let's go ahead and write down 135 degrees. You want the pi, and you want the degrees to cancel out. So 1 pi, if you just think of the unit circle, a pi is equal to 180 degrees. Okay, think of the unit circle to remember these are equivalent. So the degrees cancel out. And you can use your calculator to help you with this if you want. I'm going to do 135 divided by 180, and I will math fraction that up. And the fraction is 3 over 4, but I didn't type the pi, so it must be 3 pi over 4. I feel like I should know that answer. 3 pi over 4. 3 pi over 4 is right here. Oh yeah, that's 135 degrees. We should have known that one, right? Okay, number 8. DMS stands for degrees, and then M stands for minutes, and S stands for seconds. Okay, so this answer is in decimal form, but I want to convert to DMS form. Okay, so the way that we're going to do this is type 112.905, okay, and you're going to go to the angles command. The angles command is on top of your apps button. Okay, whatever color it is, you hit that color button. In the angles command, you're going to choose change into DMS. And so the degrees, minutes, seconds is 112 degrees. just like the 112-degree angle. It's still a 112-degree angle. 54 minutes and 18 seconds. Okay. In case the test asks you to go the other way around, you go back into your angle command. There's degrees, there's the minutes, and seconds was located someplace totally else. Do you remember where it was? Way down here on top of the plus button. So alpha plus, that's where seconds is. Very weird. Okay, so calculator for going backwards and forwards with that. Let's see, this one would probably be considered a no calculator question here. We're going to go ahead and draw a triangle, but it's got to be in the correct quadrant. So I know when we did stuff like this, let me see, I taught you things like all students take calculus, and this tells us who's positive. Okay, who is positive? Who is positive? All of them. Sine, tangent, cosine. I also kind of like just thinking back to Algebra 1. This is positive, positive, negative, positive, negative, negative, positive, negative. That also kind of helps me remember who's positive and who's negative. This would be the cosine, this would be the sine, and then you could divide for the tangent. Okay, however you learned it or whatever's best for you for remembering that. I have to draw a triangle. It says the tangent is positive. I know it says 2, but the clue here is positive. So which quadrant is it in? Positive divided by positive. It could be in quadrant 1, but it cannot be in quadrant 2. So I'm going to take that out of the mix. It can be in quadrant 3 because negative divided by negative is positive, but it can't be here, okay? So the first clue only narrows it down to 50-50, but they always give you a second clue. The second clue says that the cosine is negative. So that means it's negative comma something. Well, now I know it can't be in quadrant 1. Okay, it's got to be here in quadrant 3. Is that negative divided by negative got to make a tangent of positive? Yes. Okay, so it's definitely got to be in quadrant 3. Let's just make sure everybody writes the quadrants the right way. 1, you go counterclockwise, 2, 3, and then 4. Okay, I don't want you to miss it because you're calling it the wrong number. Okay, so we did a lot of stuff like that in Chapter 6. We used that a lot in Chapter 7. What else did we study? Here's a point on the terminal side. Okay, terminal means on the ending ray. So I'm going to have to draw a picture in the correct quadrant. Okay, and I've got the point -3, 6. So we should probably be very familiar with where this is. Negative 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, here's the point, and that's on the ending ray. Remember, you always start at the origin, go in to the quadrant, down to the x-axis. All right. Do not ever draw your triangles like this. Some people got some weird triangles. You start on the origin. Okay, it's a right triangle. -3 going this way, 6 going up. And how do you find the length of the hypotenuse? We'll have to do some Pythagorean Theorem, right? Let's see, what else was I going to say? I don't know. Okay, Pythagorean Theorem. -3 squared plus 6 squared equals c squared, I guess. 9 plus 36 is c squared. 9 and 36 is 45, but we're going to have to square root that, and we're going to simplify the radical. So 45 is 9 times 5. Radical 9 is 3, so this is going to be 3 radical 5. Remember, the hypotenuse is always positive. It's always positive. You have to put the negatives on the triangle legs sometimes yourself. Lefts and downs get negatives. Is this a unit circle? No, it's not, because the hypotenuse is not 1. It's a different value. So when I have to do cosine, I have to say adjacent over hypotenuse. I can't skip it. Okay, the two questions they wanted to ask was secant and cotangent. Okay, the way that I'll do secant is I will think about cosine. Secant is 1 over cosine. So let's go look at cosine, and then I have to flip it, do the reciprocal. So I'm not going to do adjacent over hypotenuse. I'm going to do hypotenuse over adjacent. 3 radical 5 over negative 3. Cancel, cancel is negative 5. Okay, let's go do cotangent. I know tangent is sine over cosine, but I didn't want to do that. I'm going to do cosine over sine. Negative 3 over 6 is negative 1/2. Always reduce your fractions. Okay. All right, what else did we study in the beginning of chapter 6? We did some conversions, so make sure you look back in your notes and make sure this is definitely on your note card. Okay, I always recommended starting with a picture, so I want you to draw the wheel. Be very careful when you read the problem that they're talking about radius. Sometimes, remember how we called it a diameter? The radius is 18 inches, so that's just very straightforward. It's rotating at 75 RPM. You cannot ask me during a final what RPM is, so I really hope this is on your note card. That's revolutions per minute. Okay, I recommend writing down what you have and then what's your goal? What do you want to change this into? What is the speed in mph? What does that stand for? Miles per hour. Okay, we have our starting number, we have our goal, and we have our picture. It's time to start. We made a huge conversion chart. 75 revolutions per minute. Everybody usually told me they want to do minutes and hours first. So I'm going to start with minutes. For minutes to cancel out, you put them up there, and hours down there. 1 hour has 60 minutes. Cancel, cancel. I now have hours. Check. Now it's time to work on revs. Okay, I know that revolutions have to go away, so they're going to have to go on the bottom. 1 revolution. A revolution means 1 time around a circle. Okay, look, around a circle is a fancy way of saying circumference. The circumference of this circle is 2 pi r, and you have to put units in your unit conversion. Inches. Excellent. Except I didn't want inches, I wanted miles. All right, so inches, you have to go away. If you want something to cancel out and it's in the top, we're going to put it in the bottom. Inches can get turned into feet. 1 foot, 12 inches. Wait, I didn't want feet. Okay, feet, your turn to go away. Feet can definitely get turned into miles. 1 mile has 5 tomatoes. What? 5280. 5 tomatoes. That's what a student taught me one time. Anything that's in the top gets multiplied. Anything in the bottom gets multiplied. Okay, so you go ahead and you type everything in. And what we now have is miles per hour. So let's give everybody a chance to go take their calculators out and give this a try. I really want you to try this with your calculator because there's a common error when there's a couple of things. I highly recommend alpha y equals and do the fraction. Okay, and you should have gotten 8.03 miles per hour. Okay, we got one more problem here. And this problem is about the arc. Okay, the measure of arc AB from A to B, the measure of this arc. Okay, we did this a lot with sector. It's kind of like that. I want to know the measure of this arc. It's a part of the circumference. Okay, this is an arc, and an arc is a fraction of the circumference. A sector would be an area, a fraction of the whole circle's area. Okay, so the measure of arc AB is so many degrees out of 360. and then times circumference, which is 2 pi r. The question is, what is that angle? Okay. Oh goodness, I guess this was a pretty bad problem here. This one's 87 degrees, so this angle's 87. How many degrees is that angle? I'm noticing here I made a really bad picture. I probably should have made this be a diameter. Let's just pretend this is a diameter here, and this is 87. Now I know that this is 180 minus 87, and this angle, the central angle, is 93, and that's the number I needed to know. Okay, sorry about that, guys. I'll have my secretary fix that. No, I don't have a secretary. 93 divided by 360 times 2 pi r, and the arc measure is 6.49 meters. Okay, that is a quick recap of everything we studied for Chapter 6, so please work on the problems that accompany this chapter and make sure you have your note card done.